Hi, my name is Carly, and today we're going to be doing our interactive advanced concept presentation 2, and today we're going to make a lava lamp. So first I'm going to start off with just telling you my ingredients, what we're going to be doing, and then I'm going to go over the math and the explanation behind the chemical change that we're going to do. So for this experiment, we are going to use oil. I have about 100 mLs of like lukewarm water. It's a little bit on the warmer side, and we'll get to temperature. And I have red food coloring so that we can see. And I went ahead and opened them up already, but I have Alka-Seltzer tablets here. So our main ingredients in the Alka-Seltzer tablets are the sodium bicarbonate and the citric acid. So just for reference, and I know that it's kind of hard to see, I wrote out the balanced chemical equation on paper. So we have 3 sodium bicarbs, which is NaHCO3, and this comes together with our citric acid, which is C6H8O7. And then it yields C6H5Na3O7 and carbon dioxide, 3 carbon dioxide, and 3 H2O for water. So you can see our coefficients here, and these will be the moles as well, and we'll get into the math a little bit later. So I grabbed this vase. And I might add a little bit more water actually, but for now, let me face this down. This is what we're going to be working with here. Okay, so first we'll add our water, then we'll do our oil and our dye, and I'll drop in the tablets, and we will see what happens. I wanted to say as well first, before I mix this, for our math purposes, I am going to weigh 1 Alka-Seltzer tablet and see what it is in grams. So when I explain the math a little bit later, it makes a little bit more sense. So I'm just doing 1. I'm gonna 0 this, and we have 4 grams. I don't know if you can see it. 4 grams is how much 1 Alka-Seltzer tablet weighs. So we'll keep that in mind. Okay. All right, so let's get started. So we have our glass. I'm gonna pour our water in. Let's make it 200 mLs. We're working with a little bit of a bigger glass here. Okay, that looks good. Now we're gonna add our oil. So this is approximately 200 mLs of oil, but we're gonna add a little bit more. I'll do a little bit more. We'll do another 200 mLs of oil. Oop, kind of overestimated that. Okay, so right off the bat, we'll talk about the first reaction here, just the oil and water. So this is not mixing because the oil is not polar, and it actually repels the water, but it's less dense than the water. That's why we see it rise to the top. I'm making a little bit of a mess, but that's where we see like our first reaction, or what's not reacting actually. But we'll do about like 8 to 10 drops of this. I'm just measuring with my heart here. Okay, so now is when the fun comes in. So For this experiment, I'm going to use 2 Alka-Seltzer tablets. Like I said, I only weighed one of them, which was 4 grams for one, so really we have 8 grams, but for the math later, like I said, we're just going to do the math for one. But I'm just going to break this, and we're going to drop this in. And as you can see right away, it drops right down to the bottom, and we start to see our reaction. So what's happening here? You can see the bubbles that is here, which is our carbon dioxide. That is our chemical change that's being reacting. And you can see the bubbles are rising to the top. The gas is less dense than the water and the oil, so it rises. And then you see it fall back down. This is because when this gas that is being made, the carbon dioxide gas is being made, rises to the top, the carbon dioxide is released up here, and you see the rest go back down. So gas rises, we release the carbon dioxide, and it goes back down. But actually, it looks so good. So now we will talk about the math part of this. So our limiting reactant is what runs out first, depending on how, like, it will always be the same, but when we do the math, it depends on how much that you have. So when I weighed the Alka-Seltzer tablet, it was 4 grams. So for the sake of the math part of it, let's just say that we're half and half. We have 4 gram tablet total. We'll do 2 grams of sodium bicarb and 2 grams citric acid, just half and half. So I'm gonna explain this math here as well. So how we convert this, and we're converting to see how much carbon dioxide is made with 2 grams each carbon dioxide, or so, I'm sorry, 2 grams sodium bicarb and 2 grams citric acid. So we start with 2 grams of our sodium bicarb. We do cross cancel for to make sure that they cancel each other out. So we start with grams. 84 grams is our molar mass. That is equal to 1 mole. And we set this up to be 1 mole of sodium bicarbonate on the top and 3 moles of sodium bicarbonate on the bottom. We get that from our original equation where we have 3 moles of sodium bicarb here. So 3 moles of the sodium bicarb then equals 3 moles of the carbon dioxide, which again, if we go back to our equation, we can see here is where it is yielded. And then 1 mole of carbon dioxide, we do the molar mass of that as well, is 44 grams of CO2. We do our math. If we have 2 grams of sodium bicarb, then we are able to make 1.05 grams of carbon dioxide. So that's the most amount that you can make with 2 grams of sodium bicarb. So we do the same thing on the bottom, but we do it with the citric acid. So again, we have 2 grams of citric acid because we're just saying half and half of a 4 gram tablet, of a 4 gram 1 Alka-Seltzer tablet. We'll just say 2 grams, 2 grams. We do our math the same exact way. Our molar mass for citric acid is 192 grams over 1 mole over that, and we do our math same thing. 1 mole of citric acid, which we get from our equation here, yields 3 grams of carbon dioxide, or 3 moles of carbon dioxide, sorry. So we see 3 moles of carbon dioxide on top. On the bottom we have 1 mole. That equals our conversion to grams, which is 44 grams of CO2, same as the top. When we do our math, we have 1.375 grams of CO2. So that's saying with 2 grams of citric acid, the most amount of carbon dioxide that can be made is 1.375 grams. So since our sodium bicarbonate is 1.05 less, this is less than 1.375 0.375 grams of the amount of carbon dioxide that can be made from the citric acid. That tells us that our limiting reactant is our sodium bicarbonate, because this is going to run out before the citric acid will. So that is the math explanation of it. This is an acid-base reaction, sodium bicarbonate being our base, citric acid being our acid. So this is an acid-base reaction, chemical change. Things have dissipated now, so we don't see as many bubbles rising. The carbon dioxide has been released, and we still see a separation of our water and our oil. So this was our lava lamp presentation for chemistry for our interactive advanced concept presentation 2 of our lava lamp.